Good day, ladies and gentlemen, welcome to my game dev channel. My name is Alex, and in today's video I'm gonna show you my procedurally generated recoil animation for weapons. Let's see what we've done. So here you can see a weapon in our hands, and let's try to shoot in some way, for example semi-automatic way, in ADS, without ADS. As you can see, it looks pretty smooth, maybe a little bit harder than in the real life, but it looks nice, isn't it? So let's try automatic way. As you can see, the animation changes, and we can see such smooth moving of our weapon according to its RPM, and it looks nice. But the animation for ADS should be a bit different. For example, we can multiply some values by some multiplicator, but I don't want to do it for now. Let's see how to create something like this first of all. So, okay. We have a lot of nodes here. I didn't push them in some functions or macros because it's easier to see what we done here. Okay, first of all, let's see our changing of regimes of shooting. Here, when I press O, I flip-flop these nodes, and first of all, I change the regime to automatic, then for semi-automatic way. Also, I have some setup on event begin play. Here I set my arms, my default arms. This is for ADS. And also set up animation. What we have here? First of all, let's see our animation blueprint. Here we have to set some things. But before, let's also open our skeletons of our weapon and our hands or body, if you have true first person or third person, it doesn't matter. Let's see first of all this mesh. Here I add virtual bones to head. As you can see, the first bone is gun pivot. This is one of the most important bones here, and two others are children of gun pivot, hand R and hand L, as you can see. So, what's next? Let's open our weapon skeleton. Here we have to add one socket, which is pivot point actually, and put it in any place you want. In the future tutorials we will use it for setting our animation. Okay, let's open our animation blueprint. Here we have to add several variables. First of all, gun pivot, recoil, and and nothing else actually. So first of all, we get the recoil transform from our first person character blueprint and set local recoil variable as it is. Then we also and here we doesn't set anything else. Let's open anim graph. Here on use state machines, after slot arms, we set this node, transform modify bone, choose VB gun pivot, binding our scale because we don't need it, and set these variables as it is, replace existing for rotation and translation, and in bone space, translated in both space. Then we copy bone all these nodes are almost the same. One for hand R, the second one for hand L, left hand. Check these marks here, it's important. And then again set transform modify bone for our VB gun pivot. But here we set the translation mode as add to existing and translation space as bone space for rotation and translation. Scale also should be binned because we don't need it. As a variable here, we put, as an argument, we put our recoil location variable, which we get from our first person character blueprint. Here we should get gun pivot location, which we actually also will change in our first person character blueprint, so that we don't need to get the value of it here in animation blueprint. And after all, we can do anything else, for example, making any eye case, or like to say it. So here I, for example, how to say, set my left arm to the weapon, and also here I blend my animations with my current animation with the block animation if my character is near to the wall. But this is another tutorial, and we'll talk about it maybe later. Okay, that's all for this blueprint. Let's come back to first person character, and here, as you can see, on event begin play, we set up animation, check if our anim instance is valid. If it's valid, we cast to anim blueprint. Then we get gun pivot location from here and set the values of gun pivot location, getting them from here. First of all, we get our FP gun. As you can see, we have spring arm connected with first person camera. I suppose camera connected with spring arm. Then we connect mesh to our camera. Then we connect gun to our mesh. That it is. Let's open setup animation, and here we get our gun, we get our mesh. From mesh we get this function transform ball to bone space. Set here hand R because we want to transform in right hand bone space our weapon, and so we get socket transform of our pivot point, this one, as you can see. And then after we transform to bone space everything, we can just put these values as arguments or here. Okay, then let's open event graph, and here what we can see, we have input action fire, actually left mouse button. Variable is shooting, which means we're shooting. Then we check if it's semi-automatic way or not. And here is the custom event which named shoot. If it's a semi-automatic way, we just shoot. Add controller pitch input for making our weapon each time getting up our hand or our head. Then we call this function fire, which is actually our montage for the parts of the gun, for example, for for bolt, and line trace for shooting. As you can see, each time I shoot, some line trace moves forward from the weapon, and we can see that we shoot something. Also, then we randomize recoil multiplicator. It's needed for more unpredictable animation. We can use, for example, noise here. If you have some noise library, you can use 2D noise and just use this noise as not as a multiplicator, but as a edited value. Not edited, but additional value. Then we use this recoil timeline. Let's open it. Actually, I use my curves here. We'll see them here. Let's open up what exactly recoil location and recoil. Recoil location and recoil. And actually, these curves makes our animation looks just as we want. This recoil location we need to put our weapon back recoil, and the other recoil curve is needed to rotate it in our hands in 3 different directions. So, and as you can see here, we have a timeline with length 1.2, and that's it. Nothing else here matters. And on update, we just set our recoil transform location, which we use in our animation blueprint then, as the location multiplied by -1 in this case, and only the x value of it multiplied by rotate on recoil, because we want to translate our weapon just on x direction, as you can see here. Then let's see here, rotate on recoil, we get our recoil multiplicator, which we get here, random value. Put it as an argument, multiply it by some value despite on if we are aiming or not, whether we are aiming or not, and then we get x, y, z values of this vector and multiply them by -1 and by the rotator value from our curve, and the result we just put here as a return and put here in our variable. So, as you can see that it is for semi-automatic shooting, but what about automatic shooting? If we shoot automatically, we set up our timer, get a reference of it, full auto, and each time we released our button, we clear this timer, and that's why shooting stops. Here we, as time, we put the same time as we use in our event tick, and also we loop it. Okay, and this timer calls each 0.008 seconds calls fire full auto event, which is a custom event. Then firstly we stop any animation we started previously, and then we after we stopped it, we can get our actual time as get world delta seconds, which is a fixed value, plus time, current variable. Then we firstly add controller pitch input and get a float value of it. Actually, this is the recoil up. It's needed for moving our weapon up when we're shooting automatically. Then we call delay for 1.1 second and call function fire. After we done it, we can set our recoil transform location variable. And what we did here, first of all, we get our special for automatic shooting curves, recoil lock automation. As you can see, it's a bit different in compare with just a recoil location. And also we get the value of recoil auto translation, also a bit different. Then we add it to our current recoil transform, because we want, when we shoot automatically, our weapon firstly moves back, and after it moves, we want to do anything else with the animation, as you can see. Okay, it's a bit glitchy for ADS, but never mind. So then we clamp these values. We clamp it with minimum 0 and maximum 6, then select the value depending on the distance we moved from the beginning to the current point. And if this condition is true, we can use this recoil auto translation. If it false, we will use this recoil auto translation as X translation. For rotation, we just get our vector value using this variable time, as well as here. And we get this vector value, and just call the same function as here, but instead of using random values, we use static values, hard-coded, 1.5, 0.5, 0.5. And that's all. That's actually everything we have to do to achieve something like this. But what I want to say here, to make this animation looks beautiful for automatic weapons, we have to put a lot of time and hard work, because it's actually doesn't so easy as I say. That's why I want to optimize everything I showed here, first of all, and in the future I will send a new tutorial series about the procedural animation, when I achieve something more convenient and something more beautiful. But if you don't want just to create a new Call of Duty or Battlefield or some other shooter games, but you need beautiful animation for 1-2 weapons, you can just use my code, or you can even make it more optimized if you know how. But that's the basic. Actually, we can use noises here for making the animation more unpredictable. We can use C++ for making it more faster and usable in real games. And of course, we can change all we done here. Absolutely. What absolutely? Forget. Just this tutorial is done. You can see how to create it. Just repeat for me. And in the future I will show you some other ways how we can achieve the same result or even better result. But actually I recommend you to play with the values, play with the animations, and just experiment with it. So, thank you for watching. That's all for today.